If we look back in our history, then we can find that a number of species have been completely wiped out from the earth. But those extinct organisms can be visualized and traced by using modern technology. Well, this is Gateway to Knowledge, and today I have brought a new conceptual study that how a new species have been found in the previously existing marine turtles. While paleontologists have a wealth of vertebrate fossils at their disposal, their knowledge of ecology of ancient extinct species is relatively poor, as bones and hard shells fossilize much better than soft tissues and cartilage. Scientists are limited in their ability to infer the presence of parasitic or symbiotic organisms living in or on these ancient vertebrates. As a result, relatively little is known about the evolutionary relationship between these ancient clades and their modern descendants. But all hope is not lost, as researchers can infer the presence of these small organisms from the footprints they left behind. These records are called the trace fossils. One clear example of such trace fossils is the boreholes that many mollusks make in the turtle shell remains. However, there have been no indication that such species also lived in the shell while the turtle was alive and well. In the recent study, the researchers focused on the trace evidence left on the shell of an extinct basal leatherback marine turtle. The fossil was recorded from an Upper Cretaceous formation in the Nio River, Japan. Scientists were very eager to learn more about the organisms responsible for this. And after observing the fossils closely and measuring the morphological characteristics of the boreholes, they produced a three-dimensional reconstruction of the shell and the cross-section of one of the boreholes, which allowed them to observe the intricate details left by the species. Then they saw that there were signs of healing around the mouth of boreholes, suggesting that the turtle was alive when the organism settled on the shell of the turtle. Based on the morphology and positioning of the boreholes, they determined that the likely culprit for these boreholes were bivalve creatures similar to the modern clams. These bivalve creatures are actually sessile organisms normally requiring a stable substrate to bore into, and the turtle shell was a suitable host. The fact that the host animal was swimming around freely probably helped, as this allowed exposure to new environments. After identifying the boreholes, they were unable to match the characteristics of the boreholes they were found with those made by any currently described species. This only meant one thing, that they had stumbled on a completely new species. And yes, this is the first study to report this unique behavior of boring bivalves as a symbiont of living marine vertebrate, which is a significant finding for the paleontologists and evolution of ancient boring bivalve clades. Previously, no such species have been shown to live on the shells of living vertebrates. Instead, they were often reported to occur on the remains of marine turtles and other vertebrates. By attaching themselves on a live, free-swimming substrate such as the shell of marine turtle, these bivalve creatures may have paved the way for a novel yet unknown evolutionary path of accessing previously unexplored niches and diversifying into new species. And this knowledge is crucial for understanding the evolutionary history of extinct organisms in this group. So that's all from my side. Hope you find it useful. If you did, then do like and subscribe to my channel. But if you want to purchase something from an online store, then below in the description is the link of my Amazon account. Go and check it out.